Hi B Kaushik, how are you doing? Can you please let me know if I'm audible, if you can hear me all right? Let me know about that quickly. So if I'm audible to you properly, if my volume is fine, if the audio is clear, let me know about that so that we can get started. Hello Pawan, good to see you back so soon. I don't know if this today's discussion will be very relevant to you because this is a very basic mathematics. All right, so this is mainly aimed to get the class 11 students comfortable with the maths that we'll be using in kinematics and once the other topics get started. But good to see you in any case. I'm glad that you keep watching all my videos. Good evening, B Kaushik. Hello, Manish Tiwari. How are you? So let me know if my voice is audible and the volume is loud and clear so that we can get started. Just write in the chat, good to go. Hello, hello Harshinivas. Okay, that's a long name. Dr. Harshineas. I'm sorry if I'm not pronouncing it correctly. Let me call you Harsh. All right, great then. All right, thank you so much, guys. So, welcome you guys to Unacademy JEE English. This is a brand new channel by Unacademy, India's largest online learning platform for IIT JEE. Hello, Samyak. How are you? So here everything is taught to you completely in English. The aim for this new channel is that the students who wanted to study completely in English do not feel left behind, because I know you guys have a lot of difficulty when Hindi is mixed, and that is generally the way most of us teachers teach. So Unacademy has taken this effort to bring out a completely English channel so that all the students feel comfortable here. Great. Good evening, Esmeta. So today we'll be talking about basic maths. All right. So this is again, this is part of my series which aims to help class 11 students. So I know a lot of you guys are not very familiar with basic maths also, that we'll be using a lot in our kinematics and other topics that we'll be starting. So this is here to this topic. Today's lecture will aim to get you familiar with that, so that you don't feel confused when the maths comes. All right. So before we get started, let me introduce myself one more time. My name is Rohit Dixit. All right, I've studied mechanical engineering from IIT Delhi. I have 7+ years of teaching experience, and wherein I've taught at most of the very reputed institutes in the JEE field. Good evening, Alok. How are you doing? Hello, Kushal. Good to see you here. So I myself was JEE rank 447, and I've coached many students to top rank. So yes, I've been there where you are right now. I've been in your shoes. I have felt that pressure. I prepared for this competition myself, and I cracked it very successfully, as you can see. And I hope that I can help you guys do the same. So let's move forward. So moving forward, let me also tell you about the Unacademy subscription and the benefits that this one comes with. All right, you get live classes, you get to interact with your educators, and you have live polls and leaderboards. You have test series and analysis. You have live doubt clearing sessions. So the last 2 points are very important. They will help give a big boost to your JEE prep. So, and most of all, you get access to India's best educators on a single platform with this Unacademy subscription. So how do you get this subscription? You follow these easy steps. Download the Unacademy app. Next, you go to the IIT JEE segment plus, select plus, go and select your goal as IIT JEE and click on get subscription, as easy as that. And when you are getting your subscription, you will notice that the fees already is very less. You realize that a 24th month subscription comes at a price of roughly 1500 per month, which is 50 rupees a day. And if you use my code, you get additional 10% off. So Unacademy is trying to provide you quality education at a very reasonable and affordable price. So do check this subscription out. All right. You can also join us on the Telegram app using the link that is shown above. So join us here, and this will provide you all the notifications and schedules of all the lectures that are being conducted on the JEE English channel. So let's move forward. Oh, I think I forgot to change this slide. Anyways, so we're talking about basic maths, and the first discussion of the day will be about trigonometry. In our institute, they did not include the chapter called basic maths. Well, Pawan, yeah, that's a very teacher thing. I mean, in our institute also, where I was teaching earlier, this is not a compulsory topic to discuss, but it was left at the discretion of the teacher itself. But from my experience, I've seen that a lot of class 11 students would face a lot of problems with the maths, and that is why I personally started teaching this. All right. No, vectors we used to teach. I used to teach vectors was a part of our regular curriculum. But yeah, not this. This was done on a discretionary basis. It used to depend on teachers themselves. All right. So I'm glad that here you are getting all the help that you are not getting wherever you're studying also. All right. So let's hope this helps you. All right. So we're talking about trigonometry first. I know a lot of you guys are not even familiar with trigonometry. So let's talk about elementary trigonometry. All right. So you have two systems to measure angles. First is the sexagesimal system, where the angles are measured in degrees. All right. Yes, Krishna, absolutely. That is very important, and I know a lot of class 11 students are super confused about that. Thank you, Pawan. Thank you so much. So in this system, you measure your angles in degrees. All right. So right angle is 90 degrees. 1 degree also can be broken down into 60 minutes, and 1 minute can be broken down into 60 seconds. The representations have been shown to you, right? A degree is represented as this with this sign. This means degree. When you're talking about minutes, you use this sign, right? So when you're talking about seconds, then you use double dash. All right. So let's say 30 seconds. So this means 30 seconds. All right. So this is the system of angle measurement that we use. Also, yes, I will talk about maximas and minimas also, Kushal. Don't worry about it. I'll discuss it all. So, and then there is another yet very commonly followed system of measuring angles that is called the circular system. In the circular system, an angle is defined as the length of the arc and the radius. So it's the ratio of this arc length is to radius. So if the arc length was S, so your angle in radians would be S over R. So it is a ratio of the two lengths. Okay, since it's a ratio of two lengths, ideally it should be unitless, but still we use the unit radians. All right, so radians is the unit here, and you will realize if you talk about a complete circle, in the complete circle the arc length becomes 2 pi r. So for complete circle you will realize, for complete circle you will realize that S becomes, for the complete circle, S will be 2 pi r. So what is the angle that you will get? You will get your theta as 2 pi. So which means 2 pi radians is equal to 360 degrees, or pi radians is equal to 180 degrees. That is how you can convert your angles from degrees to radians. All right. So 90 degree would become pi by 2, 45 degree will become pi by 4, and your 30 degree angle is pi by 6. All right, and so on. So let's also go over some trigonometric formula that we'll be using in our physics analysis. Yes, Krishna, I will try to be louder, okay? So let's see. First thing, if you don't know about this formula, then only this is important. If you know about it, then well and good. But a lot of people, a lot of you might not be familiar with these formulas, so I decided to discuss these also. The first very important formula is sine square theta plus cos square theta is 1. All right, again, very easy to see. How is sine defined? Sine is defined as perpendicular upon hypotenuse. So sine square would be p square over h square. Plus how is cos defined? It is defined as base over hypotenuse, right? So b square over h square. When you sum this up, you get h square in the denominator and p square plus b square, which is perpendicular square plus base square in the numerator. And you know from Pythagoras theorem that what is the numerator? These perpendicular square plus base square is nothing but h square. Alright, so you are left with h square over h square, which is 1. Alright, so that is how you get this formula. Sine square theta and cos square theta is always plus cos square theta is always 1. Similarly, next you have 1 plus tan square theta is sec square theta. I'm only discussing the important formula which you will be using a lot in physics. Alright, so there are a lot of other relations, but I've left them out. Those you will be learning in mathematics when you study trigonometry. Great, good to know. So if you already know these formula, then well and good. If you don't know, then I'm still presenting them for you. If you know also, consider this a revision. Alright. Then you have a formula of sine of a plus b, where a and b are two angles. So sine of a plus b is sine a cos b plus minus cos a sine b. So that's the formula for sine a plus b. You will be using this later when we talk about waves and all. Mostly then only we talk about this formula, and this is not used very frequently before that. No problem, Niranjan. No problem. We just started. This is the first sheet of formula that we are studying. Alright. Similarly, for cos, you have the formula cos of a plus b is equal to cos a cos b minus sine a sine b. And if you reverse the sign, you can use the other signs. Alright. Then tan a plus b will be tan a plus tan b over 1 minus tan a b. Tan a tan b. So that's alright, Ankit. You can go over the video once again if you're talking about the 4 o'clock video. Alright, you can go over that. It will be available to you. And this also, you haven't missed much. This is the first slide of formula that I'm talking about. Alright, you can check out one slide that you've missed later also. Don't worry. So, next, there are some more important trigonometric formula which we need to read. So remember we realized earlier that sine a plus b. What was sine a plus b? Sine a plus b was sine a cos b plus cos a sine b. So what happens if I make a equals b? So if a is equal to b, then this will become sine a cos a plus cos a sine a. So it will become 2 times of sine a cos a. Alright. This is nothing new. You're just substituting in that formula a equals b. So you get sine 2a as 2 of sine a cos a. You will be using this in projectile motion. Alright. Similarly, cos of 2a can be written as cos square a minus sine square a. Also, it can be written as 1 minus 2 sine square a or 2 cos square a minus 1. So here is an a missing. Alright. Good evening, Satyam. I'm good. Hope you're doing well. Similarly, tan 2a will become 2 tan a over 1 minus tan square a. In all these formulae, I'm just substituting a equals b in the last sheet. Alright, I'm getting these. Then you have a sine rule. Sine rule says that a over sine alpha equals b over sine beta equals c over sine gamma. Let's see how that comes. Alright. So, what you do is that you look at this triangle. You look at this triangle. Now let's drop a perpendicular here. Alright, so let's drop a perpendicular here. So this is a perpendicular. Let's say the height of this is some x. Alright. Now, let's take a look at these triangles. Let's call this capital A, this capital B, and this capital C. Usually the side opposite to capital C is measured as small c and so on. Alright. So, once you've dropped this, and let's call this point some O. Alright. Now take a look at the triangle. Look at the triangle OAB. If you look at the triangle OAB, what can you see from here? What is sine of alpha? You will realize sine of alpha is x over c. Right? So from here you can say that x equals c sine alpha. Alright. Okay, I'll do that. So Sunday I will conduct a quiz on vectors. Alright, don't worry, Niranjan, I will do that. Similarly, if you look at triangle OBC, okay, so let's take a look at triangle OBC. Then what do you have? Okay, so triangle OBC. If I take a look at triangle OBC, I will see my sine of gamma as, sine of gamma will become x over, you will see that as x over a. Alright. So you will realize that sine gamma is x over 8, and from here I can write that x equals a sine gamma. Now I can equate these two. When I equate these two, what I get is, equating these two will give me that a sine gamma equals c sine alpha, or I can say that a over sine alpha equals c over sine gamma. All right. So there's your proof for the sine rule. All right. You already got this. Now, once you get this, you just need to drop another perpendicular maybe here, and in a similar manner, you'll be able to prove the third part also. So sine rule says that a sine alpha equals b, a over sine alpha equals b over sine beta equals c over sine gamma. It is very easy to derive also. I don't know. Thank you, Mr. Solutionist. Thank you so much. So similarly, you have a cosine rule. And the cosine rule says that if you have a triangle like this, which is shown here, let's take a look at this triangle. I'm removing the proof. I hope everybody followed the proof of sine rule. It's very, very simple. So let's get rid of that. Now, if you look at this triangle, then if you take C and you take the angle opposite to C, then cosine rule says that C square will be equal to A square plus B square minus 2AB times cos of gamma. I can prove this also. All right. So again, by using the same logic, I could have proved this. I could have just dropped this, and using Pythagoras theorem, this can be proved, which we will do later. I think I did in vectors also. In vectors, we proved the resultant equation, remember, by dropping a perpendicular. So that was actually, the final expression that we got was nothing but your cosine rule only. You remember r square equals a square plus b square plus 2ab cos theta. There the only difference was that theta was between angle A and B, it was this, right? This will be 180 minus gamma. So when you write plus cos of 180 minus gamma, you know cos of 180 minus gamma would be minus cos gamma. All right, so it comes with a minus sign here. That is why you are getting a minus sign here. All right, because gamma is here is this angle, and there you were using the outer angle. There you were using this angle, here you're using this angle. So this is your cosine rule. Remember this, you'll be using this. Yes, I just did. No man, you are slightly late. Yes, in fact, it's the other way around. Lami's theorem comes from sine rule. Alright, Niranjan, Lami's theorem actually comes from sine rule. So, Numan have already proved it. Sabrish, as far as physics and everything related to physics is concerned, I make sure it is my business to know it all. All right. I can't be teaching it if I don't know what I'm teaching, right? So I make sure I know everything which is related to physics. Even as a student, I try to make sure of that I know my entire physics for JEE, as far as JEE is concerned. So as far as JEE physics is concerned, I try to make sure that I know everything. All right. So those are your sine rules and cosine rules. Remember these, we'll be using these. I've already proven this, and I will show you. You can watch the proof later. Don't worry, Noman. You can watch the proof later once it is. Okay, fine. let me just quickly prove the sine rule. All right. Okay. All right, Noman. Don't worry. So let me just quickly show you one more time. So what we did to prove the sine rule was we dropped the perpendicular. Okay, I dropped the perpendicular. I'm calling this point my A, this point my B, and this point my C, and I'm calling this point O. All right, this is perpendicular. I'm calling this length as some X. All right. So if you take a look at triangle OAB, what do you see? In triangle OAB, you will see that what is sine of alpha? Sine of alpha is X over C, right? So sine of alpha is x over c, which makes your x as c sine alpha. All right. Right. So how about the triangle OBC? So take triangle OBC now. What happens if you try to find out sine of gamma? Sine of gamma is x over a here. Right. You can see that this is x, this is the perpendicular, this is the hypotenuse a. All right. Right. Absolutely. So from here you can say that x equals a sine gamma. All right. Now all you need to do is equate these two. So when you equate these two, what you're getting? You're getting a sine gamma equals c sine alpha, or in other words, if you rearrange the coefficients, you're getting a over sine alpha. I think, okay, that might not be visible. So once you've equated this, what you'll get from here is a over sine alpha equals c over sine gamma. All right. You can do it very similarly. You can do it very similarly. You drop another perpendicular here. You drop another perpendicular here. If you try and find out cos sine of beta, what do you see? Let's call this y. You'll see sine beta. Sine beta would be y over a. All right. And you will see in this triangle, what you will see? Sine of alpha. Sine of alpha would be y over b. Now from here you equate these two, you will get a over sine alpha equals b over sine beta. All right. All you need to do is draw another perpendicular. Great. So now obviously you can equate these three, all three. All right, that is how you get your sine rule. A over sine alpha equals b over sine beta equals c over sine gamma. All right. Okay then. Let's move forward. Okay, now let's talk about some basic coordinate geometry. No problem, Norman. All right. So what do you know? In coordinate geometry, every point in space is represented with their x, y, and z coordinates. So let's talk about 2D coordinate geometry first. In 2D coordinate geometry, if you want to find the distance between 2 points x1, y1 and x2, y2, you do that using this formula. If you remember, we used this to find the length of a vector. The length of the vector was nothing but distance between 0, 0, 0 and x, y, z. So the distance formula used to give me that the length of the vector would be square root of x square plus y square plus z square. All right. That was nothing but we were using distance formula only. Now, let's talk about the equation of a straight line. This will be coming handy a lot. So, general form of equation of a straight line is ax plus by plus c equals 0. All right. Now, the slope of the straight line is represented usually as m, and it is tan theta. So, this is what you call the slope. The tan of this angle, tan theta, is what you call the slope of this. All right. And this is usually equal to m. Yes, we will do a quiz on vectors on Sunday. All right. Yes, Satyam. This is all very easy. Trust me. All right. So that is the general form of the equation of a straight line. Now, more commonly, we use the equation y equals mx plus c. All right. And I can derive that also. That's very easy to derive. So suppose you are trying to relate this y and this x. What do you need to do? You drop a perpendicular here, and let's say this length is some y dash. All right, so let's call this length y dash. So if you look at this triangle, so let's take a look at this triangle. All right, so this is your theta. All right, this length is x, and this is your y dash. Right, from this triangle, what you can see is what is tan theta? So tan theta is nothing but y dash over x. So from here I know y dash equals x tan theta. All right, and what is the value of y? This length was c, Alright, so your entire y is nothing but y dash plus c. Yes, Noman. I did mechanical engineering from IIT Delhi. Alright, so you will realize your y is nothing but y dash plus c, right? This entire length is y. And this y is nothing but y dash plus c. So when you substitute it here, you get your equation of y equals tan theta x plus c, which is the y equals mx plus c. This you represent as m. This is the slope. Alright, so that is where the y equals mx plus c comes from. So here, this length is called the y-intercept and m is called the slope. Alright, y-intercept is the point where the straight line is cutting the y-axis. Alright. Okay, I hope everybody followed this. Yes, it takes a lot of hard work also to get in there. And trust me, the hard work is so worth it. You earn it for life. You earn that for life. And that is one thing that should get you motivated to get into IITs. Imagine you being able to say for your entire life that I am from IIT. And earning that respect for lifelong. Alright. Now there is another form of straight line equation which is called the intercept form. Alright, so intercept form is written as x over a plus y over b equals 1. Alright, so this is where this is how a straight line can be represented like this. This is called your x-intercept. Similarly, this is called your y-intercept. Now please note, if the line was like this, suppose the line was like this, then b would have a negative value. So please remember, when you're substituting your values of a and b, you substitute them with proper signs in this equation. Alright. So if you have your x-intercepts and y-intercepts, then you can quickly calculate the equation of the straight line as x over a plus y over b equals 1. But always remember to substitute the values of a and b with proper signs. Alright. Next, why don't we practice a small problem? So you've been told a particle starts moving with an initial velocity u and an acceleration of 2 meters per second square. Draw a velocity time graph. Now, here, in case you don't know the equation, I will tell you the equation. This is the same equation that you must have studied in class 9. You know that v equals u plus at. Alright, so this is y equals mx plus c. Alright, this is nothing but v equals a would be 2, so it will be 2t plus 25. So this has the form of y equals mx plus c. Alright, so the graph should be easy. How is the graph? You will realize it will have a slope of 2 and the y-intercept would be 2. So this length would be 2 and this would be v. Why? Because instead of y I have v here, instead of x I am having t here. So I'll make this axis as my t axis, that axis as my v axis, and this will what my graph look like, and this theta would be tan inverse of 2. Alright, I hope everybody knows inverse trigonometry. Alright, inverse trigonometry, let me also tell you quickly, if sine theta is, let's say, some value x, then I can say that theta is sine inverse x. Alright, this does not mean 1 over sine theta, please remember. This is sine inverse. Sine inverse of x will be theta if sine theta is x. So sine inverse is nothing. Sine of any angle tells you the value of that sine, right? Sine inverse of a value tells you for which angle the sine would have come to this. Alright. So in case you didn't know, now you should know. These are all the inverse trigonometric functions. Cos inverse theta will be equal to cos inverse of some x will be equal to another theta. That would mean that x was cos of that theta. Alright, so theta is telling you, sine inverse and cos inverse are telling you the angles for which a particular value of cos is obtained. Similar case is with tan inverse theta. So tan inverse 2 would be the angle. If suppose the angle comes out to some theta, then tan theta would be equal to 2. Alright. Okay. Now, another very very commonly used equation in our 2D motion analysis or even 1D motion analysis, which is the equation of a parabola. Alright, so this is the quadratic equation. So graph of a quadratic equation given by y equals ax square plus bx plus c is called a parabola. Alright, where a, b and c are constants and a is non-zero. If a becomes zero, then you realize, then this is your straight line equation. So it has to be non-zero. Alright, Niranjan. Okay, Kushal. I don't even remember how the maths used to go. So that is why I mentioned inverse trigonometry. I had some idea that a lot of people might be confused about what tan inverse 2 would be. That is why I thought I'll just mention it. Alright. Yes, Niranjan, I will take care of that. I'll let the team know right today only. I think I forgot. 0,25. Yes, I think we made it like that. Oh, sorry. Yeah. I said 2. It'll be 25. You're right. Yes. Sorry. Yeah, I didn't pay attention. Thank you, Pawan. Thank you. Yeah. You're right. Alright, so this is what your equation, what the graph of a parabola looks like. Okay, so if you have your equation of y equals ax square plus bx plus c. Now this c is nothing but the y-intercept. Alright, and this is known as the vertex. Alright, so this is known as the vertex of the parabola. And this represents the lowest point. So the lowest point has the coordinates of, the x coordinate of minus b over 2a. You need to remember that. Alright. So, when a is positive, which means when the coefficient of x square is positive, then the graph opens up, which means it faces upwards. If the coefficient of x square is negative, then this graph will face downward. Alright, so you need to remember that. If the coefficient of x square is positive, this graph curves up, alright, into a smile. And if a is negative, then it turns upside down into a frown. Alright. So there is an easy way to remember this. Alright, so easy way to remember this is a greater than 0, a less than 0. Alright, so this is how you can remember this. So if a is greater than 0, you have an upward smile, otherwise you are sad. Okay, now x coordinate of the vertex is minus 2 by a, c is the y-intercept of the parabola, and graphically, this graph is symmetric about its vertex. So it will be always symmetric about this line. Symmetric means as it is on the left, it will be exactly identical on the right, right? So if at some distance, let's say some distance x1 away and x1 away, the y will have the same values. So this graph is symmetric about this line of vertex, alright? Yes, Kushal. Alright, so let's go ahead and try a practice problem one more time. You've been told that a particle starts with uniform acceleration of 4 meter per second square from rest. Plot the displacement time graph for this particle. Alright. So how will you do that? Here you will realize the x coordinate was b over minus 2a. What is the value of b here? What is the displacement equation that you use? You use the equation of s equals half at square, right? Why? Because u is 0. So half at square, a is 4. So I get my equation as s equals 2t square. So what I am realizing is a is 2, b is 0 and c is 0. Alright, these are the three things that I realize about my equation. So if c is 0, which means it crosses the y-axis at 0. Similarly, the x-coordinate of the vertex has to be 0. Why? Because it was minus 2b by a. So this graph looks something like this. It will have its vertex here. So this is what the graph will look like. But since we are talking about time, we don't take time to be negative. So that is why we get rid of this portion of the graph, and this is the graph that you will have left. Alright, this is what Yes, yes, Pavan very rightly answered. Yes, Niranjan, well said. But we only take the positive t, alright? We don't talk about negative t's while making a graph. So this is what the graph will look like. Alright, let's take another look. Here you've been told a particle is projected with a velocity upwards from ground. Initial velocity is u, and it follows the equation s equals u minus half gt square. You have to plot the displacement time graph of this particle. So here you will realize that the coefficient of t square would be negative, right? So it will be a downward parabola with a vertex somewhere in the middle. So if you try and see the graph of this, the graph looks something like this. And the vertex here would lie at t would be minus 2b over a. Remember, so what is minus 2b? That is g over a. So this vertex would be u over g. In fact, it should come out as u over g. Yeah, minus a over 2b. Right. So this would be u over g. Alright, this would be 2u over g. You can find this out by keeping the value of s as 0. So this is 0. So this is your displacement and this is your time. So that is what the graph of this motion will look like. No, Satyam, I don't have electrostatics class today. Remember, electrostatics is going on for class 12. That happens on Mondays, Tuesdays and Wednesdays. Alright. Yes, yes, Pavan rightly said. So this is what the graph will look like. So this point would be plus u over g. This point would be 2u over g. So this is completely in the middle. I told you if it is becoming 0, u over g here, then it will become 0 again, exactly u over g later because of the symmetry. So this graph will be symmetric about this line. Alright. So because of that, that is happening. Yes. Not projectile. But this is motion under gravity only. Alright, so now let's get to the calculus part of things. Alright, so this is the part that you guys fear the most. Alright, so let's talk about calculus. So first let us define function. What is a function? Yes, yes Pavan, rightly said. So what is a function? How do you define a function? So function is a rule or a relationship. Okay. So function is a rule or a relationship between two variables in which one is assumed to be independent variable and the other is assumed to be dependent. So independent is one variable which is changing on its own, and dependent is one which is changing in accordance with the independent variable. So for instance, time usually is the independent variable. Now always remember, whenever you're making graphs, by default, when you're asked to make ST graph or VT graph, you always put your s on y-axis and t on this axis. You always put your v on this axis and t on this axis. Why so? You always put independent on x-axis and dependent variable on the y-axis. Now time is independent. Time will just move on, right? Irrespective of your displacement, irrespective of your velocity, time is moving on its own. So time is an independent variable. And your position and velocities will depend on time. They will depend on what time it is. So they are called dependent variables. In making a graph, you always put an independent variable along the x-axis and dependent variable along the y-axis. All right. So yes, you can say that. A function is giving you a relation with which you can find this. So some examples of functions are, so this is an example of function. This is an equation which is telling you how to get the value of y if you know a value of x. So this is called a function, and we also denote this as y as a function of x. This is the general form of all these. So all these can be written as y being a function of x. Why? Because in all these equations, in the first two equations, in the third equation, I will write s as a function of time. Alright, so here you write the dependent variable and it is a function of whatever independent variable is there. Now, it's not necessary that every dependent variable is a function of only one independent, right? let's talk about in space. In space, you know, there are three variables that you need to specify positions. So uh, your position, for instance, position may be a function of x, y, and z, three variables. So in case it is defined with the help of three variables, then you write it as this. All right. So whatever the equation you have. So in this case, the equation of S will contain three variables, x, y, and z. All right. So, but mostly we are talking only about variables which are functions of one variable only. All right. So that is what you see most often. So this is the notation. Now, let's talk about the slope of any graph. Now, what does the slope of any graph represent? The slope of a graph represents the rate of, I think one F is extra, rate of change of one with respect to the other. Now, what do I mean by that? Yes, in waves you will have that. Wave function. Y is a function of x and t both, position and time both. Yes. So let's talk about slope. Why? Because we need to talk about the slope and we need to calculate slopes a lot of times. For instance, in general, what does the slope of any graph tell you? So let's take the simplest possible graph, a straight line. All right. So straight line, you know the slope is tan theta. What exactly is tan theta telling you? So let's see. So let's move from here to here. And let's say this was some value x2 and this was some value x1, and the corresponding values of y are y1 and some y2. All right. So here, if I make this triangle, let's talk about this triangle. All right, let's use another color. Let's see this triangle. All right. So in this triangle, you will see what is this length? This will be y2 minus y1. What will be this length? This length will be x2 minus x1. All right, and this angle will be theta. So what is tan theta? Tan theta here becomes, so if I look at my triangle, I get my tan theta as y2 minus y1 over x2 minus x1. So what you realize is, what is y2 minus y1? y2 minus y1 is the change in value of y when I move from one point of the graph to another. All right. So while moving from one point of the graph to another, what is the change in value of y? So this is often denoted as delta y. This is the symbol which means change. I'm talking about change. All right. Delta means change. So change in y is represented as delta y. Similarly, what is x2 minus x1? x2 minus x1 is the change in value of x when I move from one point of the graph to another. Alright, so this is denoted as delta x. So what I can see is that when x changed by delta x, alright, when the value of x, if x changes by delta x, what I can notice is y changes by delta y. Alright, so what happens if x changes by 1? If x changes by 1, then what do I have? If x changes by 1, how much should y change? You can use unitary method, right? So delta x change of in x produces a change in y, which is delta y. So when you change x by 1, how much change will we get? We will get delta y over delta x. Alright, this is what I call rate of change of y with respect to a change in x. So it is telling you for every 1 unit change in x, how much y is changing. Alright, how rapidly is y changing every time I change x by 1. That is why we call it rate of change. You know that rate of anything, what is it? So please teach on black background because our eyes hurt when we watch your lectures continuously for 1 hour on bright screen. Alright, next time I'll do that. But right now I've already prepared my slides with the white background. Okay, so yes, Manish, I will take care of that the next time. Alright, next time I'll make the background of my slides as black and so that I can write in white. Alright. So when you talk about rate of anything, you talk about the unit for one of that quantity. So that is what slope represents. Slope represents the rate of change of y with respect to a change in x. All right, with respect to a unit change in x. So if the y is changing very rapidly when you change x by 1. Then you say the slope is high, the slope is low. That would just mean that every time you change x by 1, the y changes slowly. Alright, so slope is telling you how rapidly is y changing when you are changing x. Alright, that is the idea of slope. Now, why are these slopes important to us? Let's see. Because most of our physical quantities are defined in terms of slopes, right? So when you talk about an ST graph, so slope of an ST graph, what is that telling you? That is telling you delta S over delta T. And you know how I define my velocity. Velocity is defined by that. Alright. So velocity is being defined as rate of change of displacement with respect to time. So in our definition of a lot of physical quantities, we define them as rate of change of one thing with respect to another. Similarly, if you notice my VT graph, and you remember how I define acceleration. Acceleration is defined as rate of change of velocity. So change in velocity over change in time, right? So that is why slopes of graphs become very important to us, because in physics, a lot of quantities are defined as rate of change of one quantity with respect to change in another. Right, meter per second, what is that telling you? If I tell you my velocity is, let's say 4 meter per second, what does that tell me? That means that every time you change your time by 1 second, alright, you move in time by 1 ahead, alright, 1 second ahead, the object would have moved by 4 meters. So that is change in the position when you change your time by 1. Similarly, acceleration, if suppose it says 2 meter per second square, what does that mean? That means every time you increase time by 1, you will see that your speed would have changed by 2. Alright, that is what rate of change of velocity means. That every time you're increasing your time by 1, by how much amount is your velocity changing? So that is why all these rates of changes of one thing with respect to another are very, very important. Why? Because we are defining things in physics that way. Alright. So that is why we are talking about slopes, and that is why we are trying to understand how to calculate slopes. Alright. So now slopes can be calculated using two methods. One is graphically and another is mathematically. Alright. So let's take a look. Alright. As I said. So let's talk about the graphical method first. How do you calculate the slope graphically? So let's take a look at this graph. So here, one way was that you could have taken 2 points A and B like this as shown. Alright, so this would be x. I've taken two time instances, or two instances in x. One x equals x naught and another x naught plus delta x. You remember, if this was x2 and this was x1, if you remember, delta x is defined as x2 minus x1, which means I can write x2 as x1 plus delta x. That is how I'm writing the second instant as x naught plus delta x. X naught the original value plus delta x is the change, whatever change happened here. Now the corresponding value of y to x naught can be calculated as f of x naught. It is the value that you get for the function when you put x equals x naught. The second value of y can be calculated as this. When you're putting the f as x naught plus delta x. Hello TRS trillions, how are you? Now, what will this slope tell you? What will this slope tell you? Yes, you missed more than half an hour, trillions. You missed almost 45 minutes. You missed half the lecture. Alright, what is this slope telling you? Let's consider an ST graph now. Had it been an ST graph, so in an ST graph, let's see. So S on this axis, T on this axis, alright. So imagine your ST graph was varying like this. Some weird graph I'm making. So if I made this time T1 and this time T2, and if I wanted to measure the slope of this straight line, alright, so I'm joining the two endpoints with a straight line, alright, and the slope of this straight line, which is theta, what is that telling you? This is the displacement in this time interval, alright, and this is the time interval itself. So the slope of this straight line joining 2 points, let's call these points A and B. So the slope of line AB is telling you delta S over delta T. You remember that is how we will define our average velocities. Yes, trillions, do that. So if I want to find the average velocity between T1 and T2, that's good, that's good. Have some practice. We are having a quiz on Sunday, all right? So the average velocity between time intervals of T1 and T2 is measured as the average slope. All right, this is called the average slope between A1 and A and B. The average slope is found by joining A and B with the help of a straight line and measuring the slope of this. Why is this the average slope? Because this is telling you on an average how S was changing with respect to time. All right, that is what I mean. Now consider, how do you calculate the actual slope at any point? The slope here is changing at every instant. At every instant, you will see that the change in S or same change in T will not produce the same change in S. If I talk about here and if I talk about here, let's say, if I talk about the same change in T, you will realize that the change in S is not the same. Right, here it was smaller, here it gets bigger. So because here I can see that every time the same change in T is not producing the same change in S. So I can say that the rate of change of S is changing constantly. So at any one instant, how do I measure that? Now, had it been a straight line, I know, straight line is very easy. In a straight line, I measure the slope simply by finding the tan theta, all right? So there is a small trick here. The small trick is that any graph that you take, so let me make a cleaner graph first, because this, okay, has a lot of lines. So let's say this is the graph. All right, and this was some point A, and this was some point B. So initially, this was the average slope. The slope of this straight line was the average slope between points A and B. Yes, integration gives the area under the graph. However, let's consider this. What I'm saying is, what happens if you break your graph into very small parts? What happens then? So let's break this graph into small parts. Let's talk about a very small part like this. Now, if you expand this part almost seems like a straight line, right? Even if, no matter how curved a graph might be. So even if you're making any curve, so let's see, let's try it one more time. So I am making a curved graph like this. So even here, if I want to see a very small part of this graph, this small part can be roughly taken as a straight line. Do you agree? Yes, vectors is finished. Yes, so every small part, a very small part of the graph can be seen as a straight line. Now for a straight line, I know that the slope is simply the slope of the straight line. So imagine if you wanted to find the slope of this point. Now the slope of line AB is telling you the average slope between A and B. Now what happens if you move closer to this? If you select your points here, so you realize this is the average slope. You realize when you are getting closer to your actual point, so this is the point P where I want to calculate the slope. If I move closer to the point P, if I make the ends of the straight line closer to the point P from here, you realize that this line is coming closer to the actual straight line that small portion here was representing. Can you see that? That earlier the line was far away, then it is coming closer. And it will keep coming closer if I keep bringing these two ends closer and closer. What happens when I almost make them into a single point? Yes, there will be a quiz. Yes, on Sunday I'm planning a quiz. Alright. So that is the idea. You take the 2 points around P and you start getting them closer and closer. If you bring them close enough, then they will start representing that straight line, which is in a very small part of P. Alright. So if you bring them extremely close, that they are almost representing a single point, then that straight line becomes a tangent. Alright, that is the idea that I'm trying to convey. that if I keep bringing all the points closer and closer, closer and closer, so if I brought 2 points very, very close, like this, so now the straight line that I make is nothing but a tangent. Alright, so that is the slope of the tangent will represent the instantaneous rate of change of y with respect to x. I don't know, Niranjan. Actually, I think you will have two or more teachers for every subject. All right, I think that is the idea. They will have more than one teacher for every subject so that you have more options. All right, just to give you more options, I guess. So that is what I was trying to say. That if you wanted to measure average velocity between two time instants, that is what you do. Now, how do you define instantaneous velocity? Instantaneous velocity would be if you're trying to measure the instantaneous velocity at some time. So you have to take a very, very, very small portion just before and just after, because you cannot have displacement unless you have some time gap. All right, any displacement will happen in some time gap. All right, absolutely, trillions. That is the idea. So what you do is you take a small time gap, and in this small time gap you measure a small displacement. Now small time gaps, as I said, delta t in general represents, delta t measures change in time. When you're trying to represent a very small change, it is represented by dt. So we use another notation which is dt. dt means very, very small change in time. So that is what we are aiming for. That is what we are aiming for when we are trying to find out the instantaneous velocity. Because for instantaneous velocity also, what is instantaneous velocity? Suppose somebody asks you what is the instantaneous velocity at t equals 2. It means that at t equals 2, how rapidly is your displacement changing if time changes. But if it is changing all the time, then you cannot take a big section of time interval and measure that, right? What you do is you maybe take a few milliseconds before and a few milliseconds after, very, very small time duration, just around 2, or at t equals 2. So let's say I will measure the displacement between, let's say, 1.9999 seconds and let's say 2.0001 seconds. All right. So if the time interval is that small, then I can say that almost the speed in this duration will be the instantaneous speed of 2. All right. Don't worry, I will explain both. This is for the students who haven't understood differentiation also. So how do I get that? I am getting that by making the tangent, and tangent is basically, I can say that tangent is touching any graph at a very small point. That very small point can be considered as 2 points which are very, very close to each other, and the slope of this tangent at this graph will represent the instantaneous rate of change of y with respect to x. So graphically, that is what you do. Graphically, you realize that the tangent at any point, so if you have to find out the velocity at P, what you do is you draw a tangent. Alright, so you draw a tangent at P as shown, and then you measure the slope of this tangent. The slope of this tangent will tell you the instantaneous velocity at P. Alright, so remember this. Wherever you need to find the instantaneous velocity. So suppose you wanted to find the instantaneous velocity at A. Then what do? You draw a tangent at this point and they find the slope of this. The slope of this will represent the instantaneous velocity at A. Essentially what is happening is that at every point what I'm doing is I'm taking slightly before and slightly after time instants. In this very small time interval, I'm trying to measure the displacement. And since this time interval is very, very, very small, I can consider this line as a straight line. I can imagine that during this duration, the speed remains unchanged, or the change in speed will be negligible. So I can see that ds over dt, that will be the slope. Why? If this is a straight line, these two time instants will have a distance of dt. These two will have a a displacement of ds. So if I look at my graph now, what is the slope of this? Tan theta, right? So tan theta can be written as ds over dt. Got it? Okay. So that is what I mean when I say slope is represented by ds over dt. It's a very small portion of the graph. You're seeing the change in s, the change in time, you're dividing them, assuming that this small portion can be treated as a straight line. Alright, that is why you're getting tan theta as ds over dt. Why? Because I'm treating that very small portion of the graph as a straight line. So normally as a straight line, I would have calculated the slope as change in y upon change in x. That is what I'm doing. So from a graph you're making a tangent, and tangent slope is representing the instantaneous velocity. Now every time you cannot make graphs and then calculate the slopes by drawing tangents. Why? You need a mathematical method also. That is where differentiation comes into play. Alright. So let's see what differentiation is. So let us say if a function y is expressed as y is a function of x given as y equals f of x. Now what happens is, okay, let me use some other color maybe. The average rate of change of the function when you're trying to calculate mathematically, as I said, if you're trying to calculate the average slope between a and b, so how do you do that? You will say that this length is delta y, right? And this length is delta x. So the average rate of change of y in this region from a to b can be calculated as delta x over delta y. It will be the slope of this line. Alright. Oh, it is there a lot. It is there a lot. Don't worry. You need a lot of differentiation to solve all your practical problems also. You will see. You will see. So I can see that what is delta y? Delta y is the initial value of y. So this is the initial value of y and my final value of y. So delta y can be written as the final value of y minus the initial value of y. Now this is my final value of y. Alright, so this is what final value of y will look like. It is the value of y when x is equal to x plus delta x. Similarly, what is the initial value of y? Initial value of y can be written like this. Why? Because this is the value of y when x is x naught. So this term, entire term is delta y. This entire term. This is your delta y. So you wanted to find the average slope as delta y over delta x. Delta y can be written as f of x plus delta x minus f of x over delta x. This is the average slope. Alright. Now if you start assuming what did I say? That when will this average slope become equal to the slope of the tangent? If you start bringing this point closer and closer. What happens if you bring a and b almost together here only? So what happens if your a and b both are almost at one place? So imagine this is your a and this is your b. So if that is the case, then all you're left with is a straight line which is a part of this tangent. Alright, now I can assume that this is a straight line which when extended sideways is essentially representing a tangent. And the slope of this tangent, that was my aim. Alright, my aim was to find the slope of this tangent. Why? Because the slope of this tangent will represent the instantaneous rate of change of y with respect to x. So how do I do that? Mathematically what we say is that we take limits and we assume that delta x tends to 0. This is how you write. This is called the first principle of differentiation. You take limit on both the sides and you assume that delta x tends to 0. So remember what delta x was. Delta x was the change in position of x. So if the change in position of x becomes very small, then a and b almost start coinciding. If delta x, this starts tending to 0. This sign means tending to, which means almost 0 but not 0. Almost 0 but not 0. That is what this sign means. This sign means tending to 0. So if delta x is tending to 0, very close to 0, almost 0, then you realize that a and b almost come together. Yes, that is a good answer, Bhavan. So when you try to find the same slope with the extra assumption that delta x is tending to 0, then you get the instantaneous slope, and instantaneous slopes are represented by dy over dx. Alright, so dy over dx is known as the derivative of function y with respect to x. Now let's try and calculate some. Alright, let's try and calculate some. So we'll talk about this later. Let's talk about one or two differentiations. So let us assume that I have an equation y equals 2x. Alright. So I'm starting with a very, very simple example. All right. So this is obviously a straight line. All right. So this is a straight line and I know its slope everywhere will be 2 only. Right. Let's just verify that mathematically also. Graphically, I can see that the slope is tan theta is 2. Right. From the graph I can see when I make the graph, I will realize that the slope is 2. Let's see if I can find the same. Let's see if I can find the same using my just derived formula. So what did I say? If I wanted to find dy by dx, so dy by dx is the slope, right? And how do you calculate dy by dx? Dy by dx is nothing but limit delta x tending to 0 f of x plus delta x minus f of x over delta x. So let's start substituting the values. I knew that y equals 2 of x. So what will be the f of x plus delta x? So f of delta x, this term can be written as 2 times x plus delta x. Alright, this is how you write this term. Minus, let's see about this term. This term can be written as 2x itself over delta x. Alright, so when you solve this, what do you get? You get this 2x cancels. Alright, so this cancels with this. You're left with limit delta x tends to 0 and you're left with 2 delta x over delta x, which is giving me 2. Now you realize limit x tends to 0 does not matter. I have got a constant answer. Constant answer means it doesn't matter. Yes, I am getting a constant 2. It doesn't matter at what x I am. Right? Everywhere the slope will be 2, which is true in case of my straight line. The slope is 2 whether I'm here or I'm here or I'm here in x. Okay, so I can go anywhere in x and I will see that the instantaneous slope every time is equal to the average slope. That was the logic we were using earlier also. The instantaneous slope is always equal to the average slope for a straight line. So that is what we are trying to do. We were trying to make a very small straight line, and if I can find the average slope of that straight line, I know instantaneous slope will be the same. So here we have proven that. So from here I can say that dy by dx of 2x would be 2. 2. Alright, I've just proven that result. Let's try and find the differentiation of one more thing. Okay, don't worry. In my class, I will try and I'll try and answer. All right. So this graph I already found dy by dx for this graph is 2 and it is independent of x. So mathematically now I don't even need to draw the graph. Using dy by dx, I can directly calculate the slope and I can, without making the graph, tell you the slope at any point is 2. Now let's take another look. Let's try another graph. All right. The graph that we will be talking about now, let's see. Let's talk about another graph, y equals x square. Alright, or initially, let's say if you had y equals x, then what I would have found my dy by dx as 1. Right, the slope would have been 1. Now let's talk about y equals x square. How much is the slope at any point? So I know the graph looks like this. So one method was that I draw tangents and measure the slope of this tangent if I want to measure the slope at this x. Next, what else can I do? I just learned a new thing, how to calculate dy by dx. So let's try and do that. I again know my dy by dx. So I know my dy over dx is f of x plus delta x minus f of x over delta x with, okay, I forgot to write the limit part, so let me rewrite that. So dy by dx is equal to limit delta x tending to 0. So we are only limiting ourselves to this condition where delta x will be tending to 0. So let's try and start substituting the values. Alright, so I can write limit delta x tending to 0. What will that be? So what is this? This is f of x plus delta x. So f of x plus delta x can be written as x plus delta x whole square. Alright, why? Because y was defined as x square. Yes, it will come out to 2x, but let's see how. Minus f of x. F of x becomes x square over delta x. So when you expand the above expression, what do you get? You get x square plus delta x whole square plus 2x delta x minus x square over delta x. Alright, so this get cancelled. Now this will get cancelled with this and this. So what am I left with? I'm left with limit delta x tends to 0 and delta x plus 2x. Now because I had the assumption that I am limiting myself to the case where delta x tends to 0, so I can think that when I'm adding these two, delta x will roughly tend to 0 and this result will be 2x only. Alright. Thank you, Manish. Thank you so much. Alright, so that is how you're getting your differentiations. Alright, so now you can write for this as dy over dx equals 2x. Now you saw how lengthy it is to calculate the dy over dx, right? So I can't keep doing this every time I want to find the slope, alright? For theory of physics, Pallavi, I would advise University Physics by Young and Friedman or Fundamentals of Physics by Resnick and Halliday. These are the two books I recommend. These are international books. So absolutely wonderful theory, absolutely correct theory, no error, because these books have been around for more than 40 years. Alright, so these are very old books, very reputed books, internationally reputed. So their theory is absolutely correct, no errors in them, and very elaborate theory and good explanations. Alright. So you realize, even for y equals x square, I had to put in so much effort. What happens if I want to find the dy by dx of x cube? You realize the process will keep on getting lengthier and lengthier. Alright, so somebody solved all this, somebody, trust me, solved all this, and then he realized that we are getting some common results. Now, all we do is we memorize those common results so that I don't have to calculate all this again and again. Alright, I don't want to do this maths again and again. That is why some common results that have already been derived by a lot of calculation are presented here, and you can just memorize these results. Alright. Yes, very good. Yes, absolutely you can. 2 years is more than enough time. Alright, so these are some common results. You need to memorize them so that you don't need to do all that maths in one go every time you're trying to find. The best problem book in my head is always HC Orma. That has been always my favorite problem book. It starts very easy. It builds up the level of questions. I think the questions have been very beautifully designed in that book. If you look at the first few problems, they are simple, very, very simple problems. Then slowly the problems start getting complex. And by the end of it, I think the problems get pretty complex. Alright, so it builds up. Also, when you see problems of HC Orma, all the big problems, good problems have been broken down into small parts. And they ask you to solve those small parts first. You realize if you solve it carefully, it is guiding you how to think about solving a problem. Alright. So let's memorize these results. d by dx of x to the power n is n times x to the power n minus 1. You need to memorize this. d by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of tan x is sec square x, d by dx of ln x is 1 over x, and d by dx of e to the power x is e to the power x. It is good, it is good. It is very good for the theory part and also problems also. Halliday also has a good collection of problems. So you can refer to the theory of that book, but I would always advise solve HC Orma first and then solve your problems of Halliday. Alright. So remember and memorize these results so that you can find your derivatives very quickly. So let's practice all of them. Suppose, so here, if I was told that y equals x to the power 5, alright, y equals x to the power 5. What is dy by dx? So let's see. I know here my n is 5. So the result should be n times x. So I will write 5 times x and power of x will be n minus 1. So that is 5 minus 1, that is 4. Alright, so that is how I will get the dy by dx of any x to the power something. Alright. Start reading your theory from Halliday. Solve your problems first from H.C. Verma. Alright. 5x to the power 4, not 4x to the power 4. Yes, trillions. So similarly you can find all these. Alright. Even if you had this as, suppose you had another function. Let's say you had y equals 7x cubed. Now in this case, what you do is the dy by dx is calculated as 7 times dy by dx of, or d by dx of d over dx of x cubed. That is how you calculate. And what is d by dx of x cubed? So you can say that dy by dx in this case will be 7 into, now here n is 3, so I will have 3 into x to the power of 3 minus 1, right? 3 minus 1. So what I get is 21x square. That will be the dy by dx of this. Yes, absolutely. Thank you so much, Pallavi. Thank you so much. Alright, so this is how you calculate slopes using these formulae. Alright, so sin x you have a direct formula, cos x. For cos x you have a direct formula minus sin x, tan x you have sec square x. For log x to the base e, that is ln x, you have 1 over x. Thank you so much. And e to the power x gets e to the power x. So let's try some problems. Alright. So let's see. A particle starts from rest and its angular displacement in radians is given as theta equals t square over 5 plus 5t. Calculate the angular velocity at 5 seconds. Now angular velocity, omega, is defined as, we haven't talked about this, so I'm telling you already, but omega is defined as d theta over dt. It is defined as the rate of change of angle with respect to time. So theta has already been given to you as a function of time. All you need to do is find the value of d theta by dt at t equals 5. That will give you the omega at 5. Alright. Yeah, for class 11 students I'm taking. Yes, I think you will be correct. 7. 2, 2, 5, 5, 2, and 5. No, why 7? Why 7? Do it again. Pavan, do it again. It's not 7. Oh yeah, it will be. Sorry. It's 7. Yeah. Absolutely. Sorry. My bad. So theta has been told to you as t square over 5 plus 5t. Yes, d theta by dt will be 2t over 5 plus 5. Yes, at t equals 5, it is 7 only. Yes. So 7 radians per second, that will be my answer. No, it will be 7. It will be 7. Yeah, I also tried to do it orally and I think I got it wrong. No problem, but. Alright. Yes. Great. Let's take another example then. Alright. A balloon is filled with air which is heated. The area at any time is given as A equals 5t square plus 3t plus 4 meters square. You'd find the rate of increase of area at the end of 3 seconds. Alright, find the rate of increase of area at the end of 3 seconds. Let's try this one. Yes. Well done. Absolutely. When you differentiate this, your dA over dt would be the derivative of this. Derivative of this would be 5 into 2 into t to the power 2 minus 1, alright, plus 3 into t into 1 into t to the power 1 minus 1, alright, and the derivative of constants is 0, alright. Derivatives of all constants are 0 because they are not changing with respect to time. So when you solve this, this becomes 10t plus 3. Why? Because t to the power 0. So at t equals 3, this will be dA over dt would be 33. Alright. And what will be the unit? Meter square per second. Because in the numerator you have change in area which will have units of meter squares, and in denominator you'll have t which is seconds. Alright. Yes, well done. Alright. Let's also talk about some simple variations of the formulae that we studied earlier. Let's see. So you have these formulae, and now let's see how to get the derivatives of some complex formulae using this. Alright. So here I've already told you. You need to remember a few rules. What? That if some, let's say some y is defined as one function of x plus some function of x like this, then dy by dx will be, oh, this is another representation by the way, let me tell you. If y is a function of x, then dy by dx is often represented as f dash x. Alright, this is called the first derivative of the expression. If you want to find the slope of this function, you realize this is also coming out to be a function of x. So you can also differentiate this one more time to find the slope of this. If you differentiate it a second time, alright, if you differentiate it a second time, then you write that as d2y over dx2. That is the traditional notation that we use. This means that this function has been differentiated twice. I have differentiated it 2 times with respect to x, and this is also denoted as f double prime x. So 2 dashes means I have differentiated fx 2 times. No worries. Similarly, if you differentiate this also, so you have differentiated this function 3 times now. So if you have differentiated this 3 times now, how do you denote that? You denote that as d3y over dx3. This means that function y equals fx has been differentiated 3 times. And it is also represented by 3 dashes here. So f triple prime x. Alright, meaning that this function was differentiated 3 times. Alright. So that is the notation. You should be familiar with this. That if I'm talking about d2y over dx2, then I mean that I have differentiated y equals fx twice, alright, with respect to x. So, as I was saying, that if you talk about some y which can be denoted, if your y can be denoted as sum of 2 functions of x, then dy by dx would be sum of the individual derivatives, alright. So what do you mean? Let's see. So suppose you have another equation of y equals x square plus 2 sine x. Suppose I have y defined like this. So what will be my dy over dx? Dy over dx will become individually the derivative of this. Individually the derivative of this is 2x plus individually the derivative of this, which is 2 times cos of x. Alright, that is how I can write my dy by dx. So remember this rule, that if some y is sum of 2 functions of x, then the dy by dx can be written as the sum of the derivatives of individual functions. Alright. No, not minus. Not minus. I'm sorry, trillions. Yes, 2x plus 2 cos x. You can see here, d by dx of sin x is cos x only. Alright. Right. Similarly, as you can notice, something we have already been using. What we have been using, is y equals, if you have a function which is a times f of x, where a is a number, a is a fixed number, then dy by dx in such a case becomes a times f dash x. Alright, so remember this. We already used this right now, alright. So you can remember this also. Then there are other rules. There are other rules which will help you differentiate even more complicated functions. Those rules are called chain rules, product rules, and quotient rules. But I think I will start the discussion about those rules tomorrow only, because I don't want to start it right now and then leave it in the middle, because that discussion I want to take, use my time to have that discussion. All right. I don't want to finish that in a hurry. So I think we'll stop our discussion for today here only. Go through this video, practice some problems on your own. Tomorrow we'll discuss chain rule, product rule, quotient rule, and integration. All right. So we'll leave all that for tomorrow. So that is it for today from my side. I hope this video helped you guys. Quiz on vectors would be on Sunday. All right. We'll plan that on Sunday. So let's keep it till here. I know a lot of you guys also attend maths classes. All right. So I won't keep you waiting for too long. But before I leave you guys, let me tell you one more time that you can get the Unacademy subscription using these simple steps. Install the app, go to the plus segment, select your JEE as goal as IIT JEE, and click on get subscription. All right. And you can always use my code RDLive to get your subscriptions. If you want to study from me, you will get a 10% discount. If you like today's video, if you think it helped you, then please like it and share it with your friends. Also, don't forget to press the bell icon. It will notify you about my future lectures and schedules. Now, the PDF of all these slides that are used in today's lecture will be attached, and the download link will be available in the description box by tomorrow. Alright, so you can come back tomorrow, check out the description box and download all the PDFs used in today's lecture. Also, do not forget to join us on the Telegram app using the link shown above. Alright, there is your link. Join us on the Telegram app for the JEE English channel using that link. I will announce it tomorrow. Trillions, don't worry. Alright. So before I go off, one more time, let me remind you that my referral code is RDLive. Use this code to get your subscriptions and get 10% off. Alright. Thank you guys, and I will see you guys tomorrow. Till then, take care. Bye-bye. I will tell you the time of the quiz tomorrow, Trillions. The quiz is on vectors. The absolute time does not matter. It will be sometime in the afternoon. All right.